Kia ora, Year 11 and 12. This is one of the starter questions from today. Most of you didn't look at this because you were doing other work, but I thought it was worth videoing anyway. So it's a differential equations problem from 2016's March paper, and this is it here. So we've got a DE that is probably a little bit trickier than average, but as usual we've only got one thing that we know how to do with DEs, and that is to separate the variables. So this is my differential equation here, and I'm told very simply that when x is 0, y is 0. We have to solve the DE, and then we have to explain briefly why x can only take values less than 1. You can probably guess already, because this has got an e in here, this is going to be something to do with logs. So let's start off, and this is a 7-mark question, and it's one of these ones where if you spot what to do, it's absolutely fine, and if you don't, it's not so fine. So to separate the variables, we have to have x's and y's separate. At the moment they look like they're mixed up in here, but they're not, because we can rewrite this as e to the x times e to the y, and this method of splitting up indices in power problems is extremely useful. So suddenly now we can separate the variables, and we're going to get all of the x stuff over to keep it on the right hand side. So we're going to have 1 over e to the y dy is equal to x e to the x dx, and we're going to integrate each side of that. So here, this is e to the negative y dy, and here we're going to do integration by parts. So let's just write that out again. Okay, so on the left-hand side, this will anti-differentiate to give me negative e to the negative y. And we're going to keep the constant of integration over here on this side. So this term here, the x, is going to be what we either leave or differentiate, and this is going to be the bit that we integrate. So integrating the e to the x and leaving this will give me x times the integral of this with respect to x, e to the negative x, minus the integral of 1 times e to the x dx. Now, if you're rusty on integration by parts, you know what I'm about to say. Go and chug through some of those exercises from the textbook. Oops. So it's minus e to the x here plus c. What have I got now? And over here we've got negative e to the negative y. Now look, just notice that here I've written this as plus c because, as usual, this is an arbitrary constant. I could have written it as minus c, but it just doesn't matter. So we'll just shove it in there as plus c. Now is probably as good a time as any to use the initial condition that we've got. So x equals 0, y equals 0. Let's see what we have. So we have negative e to the 0 is equal to 0 minus e to the 0 plus c. The negative 1 is equal to negative 1 plus c. So our constant of integration, happily, is c equals 0. So this is where we've got down to. Now we'll go back and just clean it up and substitute in that constant. So negative e to the negative y is equal to x e to the x minus e to the x. We need to solve this, and we need an expression for y. So let's multiply the whole thing through. We get e to the negative y is equal to e to the x minus x e to the x. And I'm now going to take logs of both sides. So that gives me negative y is equal to the log of e to the x minus x e to the x. So y is equal to negative log of e to the x 1 minus x. And that's as nice a solution to that DE as we can get. I guess the only other thing we could do is we could say that y is equal to, let's rewrite this. We could do it a little bit more nicely. We could do log of, so here we've got e to the x times 1 minus x to the power of negative 1. I think it's fine to stop there though. And this gives me log of 1 over e to the x times 1 minus x, which is equal to the log of, yeah, well, we can just leave it like this, I think. I think I'm starting to go around in circles. Let's see. This is the log of 1 minus the log of e to the x 1 minus x. But that, of course, gets me back to where I was. So I've now gone completely around in a circle in a video, not for the first time. We could, though, split this up into 2 bits. So we get negative log of e to the x minus the log of 1 minus x. And I think if you write it like this, it makes it really obvious why we need that condition. So that's our 7-mark part. But the last question was to say, explain briefly why x can only take on values less than 1. So we need two conditions here. We need e to the x greater than 0, and that's fine for any x. And we also need 1 minus x greater than 0 for this bit here. So 1 minus x greater than 0 means 1 has to be greater than x, which means that x must be less than 1. So we've shown what was needed. So that's the last mark in here. If you didn't take the DE all the way through to here, you could do it from here just as easily by saying that this term is always positive, and so we need this one to be positive, and that will happen when x is less than 1. Okay, that's all there. Make sure that you're really confident with that technique of splitting up the x plus the y. I'll do a couple more of the starter questions later on tonight.